All right, Year 12, I'm going to go over exercise 602, stationary points, on this chapter of applications of calculus to curve sketching. And today, or in this video, I'm going to look at the nature of stationary points, and in particular, determining the nature of a stationary point. All right, now, there are three types of stationary point. And I'm just going to draw the three examples side by side. And you're going to say there are four, but then we'll refer to one. Okay. So we get a stationary point. And remember, our whole course, the whole Mathematics Advanced course, is based on, or it's a calculus-based course, which means it's all about calculus. And when we're doing differentiation, remember that what you are finding when you differentiate a function is you are finding the gradient function of that. That means it will tell you the gradient of the tangent at any point on the function. Now, the gradient at this point here is 0 because I get a straight line. Here, it's 0. Here, it's 0. And here, it's 0. So these are my stationary points. And they're the different types of stationary points we can have. Now, it looks like there's four, but we're going to group these two together. So, first of all, think about what we're doing in this course. And what we're doing in this course is we're finding the gradient of the tangent. So here, if I were to draw a straight line down here, that's going to be a tangent at this point here. And the gradient of the tangent at that point is going to be negative. So I've got negative, 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 negative. And they'd be getting very flat now until we get that 0 one. Then afterwards, if I go along here, if I draw a tangent at that point, well, that's a positive tangent or a positive line, which would have a positive gradient. So up here, all of a sudden, my tangents become positive. Now, by the same process, they're all positive, and I get to 0, and then I start going negative. Here, they're positive. It hits 0, but the tangents are still going to be positive as I go up here. And here, they're coming down. And I'm looking at all my functions from left to right, it's how we do it, and negative as well. So, I get a stationary point when the first derivative, y dash, equals 0, or f dash of x equals 0, or dy dx equals 0. When any of those things happen, I get a stationary point. Now, so here, the nature of this stationary point. Now, there are two types of tests we can do to find the nature of the stationary point. We can do the first derivative test. The first derivative test. Now, if you're watching this and you've been away, I want you to leave some space underneath where you're making these notes. So you make these notes in your book, because underneath the first derivative test, we're going to do the second derivative test to determine the nature of the stationary points that we find. So let's imagine we found a stationary point and we found that y dash equals 0 or f dash of x or dy dx equals 0. And I want to determine, well, is this stationary point on whatever function I've got, is it going to be this sort of stationary point, is concave up, the first one? Or is it going to be the second one where it's concave down? Or is it going to be the one that's going up, concave, it's concave down and then it becomes concave up? Or is it going to be the third one, which is concave up and then turns into concave down? Well, you can find out because all of them have a different thing that happens either side of the stationary point, and it's a gradient. So the first one, which is, and I'm going to try and create some space here, so I'm going to rub these out. You should know how to find a stationary point. So this is a minimum turning point. And this is a maximum turning point. And these two here, they're horizontal points of inflection. Now, if you go looking back in previous HSCs, they will spell inflection like this. I don't know why we spelt it like that, but now we spell it with the ECT. It doesn't matter, just be aware if you see them. So we have to determine when we find a stationary point what it is. We have to determine its nature. So to do that, we look either side. So the first derivative test, if f dash of x equals 0, well, if we look a little bit to the left, f dash of x minus a little bit, and if it's less than 0, if it's negative, and then on the other side, f dash of x greater than 0, or sorry, f dash of x plus a little bit, is greater than 0, then we get this. We get a minimum turning point. So if we look either side and it's negative and then positive, well, it's a minimum turning point. If, on the other hand, f dash of x equals 0 and f dash of x minus a little bit is positive, and f dash of x plus a little bit is negative, well, we're going to get a maximum TP. And finally, if we've got f dash of x and we look at f dash of x minus a little bit, and if it's positive, and f dash of x plus a little bit is positive still, well, it's the first horizontal point of inflection. And if f dash of x, sorry, I've got the right equals 0 there, dash of x equals 0, and f dash of x minus a little bit is negative, and f dash of x plus a little bit is negative, well, then it's the second type of horizontal point of inflection. Now, you just have to have that in your notes. And again, as I said, leave space underneath because in the next section, we're going to do the second derivative test. So we're just going to go straight into this. Now, if you're doing these questions, there's no need to do all of these parabola ones. All right, so we're going to do 1, 2, then we're jumping to 6. Why? Because if you know what these curves are, you already know what the stationary point is. I mean, look at the first one. Y equals x squared minus 1. Well, we know what that looks like. Yeah? Here's y. Right, there's your axes. And y equals x squared minus 1 is just that. At minus 1, 1, 1. That's what that looks like. And here's the turning point, the stationary point, and it's a minimum TP. Now, yeah, we can look at that and say graphically we know what's going on, but we want to go through this process. So I'm going to take y equals x squared minus 1. And then I'm going to go y dash equals 2x. And then I'm going to go, well, first of all, it says find the stationary point. So the stationary point, and this, I want you to, in your notes, set it out like this. The stationary point when y dash equals 0. So show the examiners you know what you're doing. Therefore, 2x equals 0. Therefore, x equals 0. Now, there are a couple of things. When you find a stationary point, you've got to find the y coordinate and you've got to show what it is. So the first thing I'm going to do is when x equals 0, y equals 0 squared minus 1, minus 1. So I have a stationary point at 0, minus 1. Now I have to determine the nature. Well, I'm going to go f dash a little bit to the left, f dash of minus 1. Now remember, f dash is 2x. 2 times minus 1 is negative 2 is less than 0. Then I'm going to go a little bit to the right of that x value. So I'm going to go f dash of 1. And 2 times 1 equals 2, which is greater than 0. Which means I must have, it goes from negative to positive, means I'm going to have this, because it goes negative, 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 0, positive, positive, positive. So I have a min TP, and it's good enough just to write min TP. And that's how you set it out. I'm going to do question 2. You have a go at it before me. All right, so here I go. Y equals x to the 4. Therefore, y dash equals 4x cubed. Therefore, stationary point, I'm going to start using abbreviations now, when y dash equals 0, therefore 4x cubed equals 0, therefore x equals 0. When x equals 0, y equals 0 to the 4, which is 0. So I've got this point 0, 0. I have to look a little bit to the left of the x value. So I'm going to find f dash of negative 1. And f dash was 4x cubed, so 4 times negative 1 cubed is negative 4, which is less than 0. Then I'm going to go a little bit to the right of 0. F dash of 1, well, that equals 4 times 1 cubed, which is 4, which is greater than 0. Therefore, I've got the same, exactly the same thing. Therefore, it's a minimum TP. Now, I don't want you to do any more of those parabolas because they're pretty obvious. This is a negative parabola, so it's going to be max TP. That's a positive parabola, minimum TP. That's the next one is going to be a negative parabola. The first thing I want to do is a cubic. So jump to question 6. Now, question 6, y equals x cubed minus 6x squared plus 5. So now that we've done those ones, I'll just get rid of them. And I'll jump in here and we'll go to question 6. So, question 6. Y equals x cubed minus 6x squared plus 5. Excuse me. Now, this is a cubic and it's a positive cubic. And 90% of the time in the advanced mathematics course, I say 90, but a large percentage of the time, it's been a cubic. So you've got to know what a cubic looks like. Now, positive cubic can look like that. That's your standard y equals x cubed. Or it can look like this, which means our stationary point could be this horizontal point of inflection, or it could be these two turning points. Now, knowing what they are, knowing that it's a positive cubic and it's more than likely to be this one, means that you know where you're going, which makes it easier to get the question right. So the first thing you do, differentiate y dash 3x squared minus 12x. Is that what we've got? 3x squared minus 12x? Yep. Now, let's stationary points when y dash equals 0. Therefore, 3x squared minus 12x equals 0. Therefore, we take 3x and we're left with x minus 4. So our two stationary points are going to occur at x equals 0 and at x equals 4. Now notice that I write these from left to right. So I put the one that comes on the left first, so 0, and then the one on the right. I just want to keep things neat and tidy. I want to keep them logical, so it's really easy to follow. First of all, let's find the y value. And the y value, 0, is going to be 0 cubed minus 6 times 0 squared plus 5. And it's important that you actually go through this process. You get 5. So my first stationary point is at 0 and 5. And my next stationary point will be at 4 cubed minus 6 times 4 squared plus 5. And I'll pull up my calculator for that, and I go 4 cubed minus 6 times 4 squared plus 5. I get negative 27. So I've got this 4 and negative 27. So now I've got these two stationary points. So I'm going to find f dash a little bit to the left, f dash of negative 1. So if I look at f dash of negative 1, remember f dash is 3x squared minus 12x equals 3 times, you better put your negative 1 in brackets, squared minus 12 times negative 1. Now I'm going to do this a fair bit. So I want to show you a trick on your calculator, which you may or may not already know. I'm just going to put negative 1 in there. Let's get rid of that. Negative 1. I'm going to put that, and that's now going to form my answer. All right? And now, rather than write 3 times negative 1 squared and having to worry about brackets and stuff like that, I'm going to go 3 times my answer, and I don't have to worry about parentheses, and I'm going to square that, and I'm going to go minus 12 times my answer, and I get 15. Now, why is that so cool? Because now when I do f dash of 1 equals, and I still show this 3 times 1 squared minus 12 times 1, which I know is going to be 3 minus 12, so it's going to be negative 9. But if I go back to my calculator, all I have to do is now type 1. That's now my answer. And I use my back arrow here, my top arrow, to go back. And I'm just back in there. Now it's going to now put my answer of 1 in. I'll just press equals, and I get negative 9. So now I know this type of stationary point. So it goes from positive to negative. So it's a max TP at 0, 5. Now I'm going to do the other one. I'm going to do f dash of 3 equals 3 times 3 squared minus 12 times 3. And I go back to my calculator, and again, all I do is I press the number 3, press equals, use my back arrow up the top, get it, it's going to put 3 into that, hit return, equals, and it gives me negative 9. Is that right? That's going to be 27 minus... That can't be right. I'm going back. I don't reckon that's right. All right, so it's still doing the same thing, so I've got to try 3. Use my top arrow. -9. Oh yeah, because it's 27 minus 36, so it is right. And that's less than 0. And now I'm going to do f dash of 5 equals 3 times 5 squared minus 12 times 5. And again, I go back to my calculator. This time I type in 5, go yep, use my back arrow, equals 15, greater than 0, goes from negative to positive, therefore max TP at 4 and negative 27. And that's all you have to do. Now, it is important that you go through and you do all the cubics. Here, when you get to question 10, it tells you just to find what m is. So that's just a substitution. You differentiate. It tells you a stationary... Well, I'll do it. Let's have a quick go at it. And then you can go on with the other ones. So f dash x. So here's question 10. F of x equals... or y equals x to the 5 minus x to the 5 plus mx cubed minus 2x squared plus 5. So f dash of x equals 5x to the 4 plus 3mx squared minus 4x. Therefore, it says stationary point when x equals, what they say? -1. So that means 5 times -1 to the 4 plus 3m times -1 squared minus 4 times -1 must equal 0. So -1 to the 4, and that's just 1, so I get 5. -1 squared is just 1, so I get 3m. And 4 times -1 is -4, so I get minus -4, so plus 4. Therefore, 3m plus 9 equals 0. Therefore, 3m equals -9. Therefore, m should equal -3. And I'll just check on my other computer to make sure that that is right by checking in the answers. Where are they? I've got to be able to find these things now. But I'm pretty sure that that's going to be correct. Answers. What exercise is it? 602, question 10. 602. Here we go. 602, question 10. M equals -3. Perfect. So make sure you go through and you do these and you do the cubics. You are going to get, except for 2021 when they changed it all around, you are going to get a cubic or you are going to get a quartic. They might throw something curly at you like they did the other year and give you an exponential, so something like that. But most of the time, it's a cubic or a quartic. All right, good luck.